Bougainville Island, November 1943. The temperature hung at 95 degrees with 90% humidity, turning the jungle into a suffocating green hell. Marine Corporal James Mitchell crouched behind a fallen log, his hands gripping something that looked more like a science experiment than a weapon. Two cylindrical tanks strapped to his back, connected by hoses to a wand-like nozzle. The M2 flamethrower weighed 68 pounds fully loaded, turning every step through the mud into an act of endurance. 50 yards ahead, invisible in the dense undergrowth, Japanese defenders had turned a system of interconnected bunkers into a fortress. 3 previous assaults had failed. 22 Marines were dead, pinned down by interlocking fields of machine gun fire from positions that couldn't be seen until you were close enough to die. The 3rd Marine Division had discovered what every Allied unit in the Pacific would learn. Traditional infantry tactics didn't work in jungle warfare. You couldn't flank what you couldn't see. You couldn't suppress fire coming from reinforced positions buried under logs and earth. Artillery shells disappeared into the canopy or buried themselves in soft ground without detonating. The Japanese had studied defensive warfare and built their positions accordingly. Mitchell had volunteered for flamethrower duty 3 days earlier, motivated by anger after watching his best friend die from a sniper he never saw. The training had been brief. Point the nozzle, pull the trigger, pray the igniter works. Nobody mentioned the terror of carrying 10 gallons of thickened gasoline on your back while people shot at you. Nobody explained what it felt like to become the single most targeted man on the battlefield. What Mitchell couldn't have known that morning was that he was wielding the weapon that would fundamentally change Pacific War combat. Within 18 months, the M2 flamethrower would evolve from experimental equipment to the most feared weapon in the Allied arsenal, a tool that turned impregnable Japanese fortifications into crematoriums and broke the will of soldiers who had sworn never to surrender. The story of how a device that sprayed burning fuel became decisive in jungle warfare is about more than technology. It's about how desperation breeds innovation, how warfare adapts to terrain, and how psychological impact can matter more than explosive power. It's about the moment when fire stopped being just destructive and became a weapon of conquest. The M2 flamethrower had emerged from desperate necessity. When American forces began their island-hopping campaign across the Pacific in 1942, they encountered a problem that conventional weapons couldn't solve. Japanese defenders, following orders to fight to the last man, built defensive positions that were nearly invulnerable to standard infantry weapons. These weren't simple foxholes or trenches. Japanese engineers had perfected the art of fortification, constructing elaborate bunker complexes with multiple firing ports, interconnected tunnels, and overhead protection that could withstand direct artillery hits. The positions were typically built into hillsides or coral ridges, using the natural terrain for additional protection. Logs were stacked and covered with several feet of earth, creating roofs that could absorb even direct hits from 105mm shells. The Chemical Warfare Service, despite its ominous name, had been experimenting with flamethrowers since 1940. The early models were disasters. The M1 flamethrower, introduced in 1942, was temperamental, unreliable, and dangerous to its operator. It used a compressed gas propellant system that frequently malfunctioned. The fuel, standard gasoline, would ignite but dissipate too quickly, creating impressive flames that lacked sustained burning power. Operators reported that the weapon was more likely to get them killed than help them kill the enemy. The breakthrough came from an unlikely source: napalm. Developed by a Harvard chemist named Louis Fieser in 1942, napalm was a mixture of naphthenic and palmitic acids, combined with gasoline to create a gel that stuck to surfaces while burning at extreme temperatures. When mixed with gasoline in the right proportions, it created a substance that could be sprayed, would stick to whatever it hit, and burned at temperatures exceeding 1800 degrees Fahrenheit for up to 10 seconds. The M2 flamethrower, introduced in 1944, incorporated napalm-thickened fuel and solved most of the M1's problems. The system was elegant in its brutality. 2 cylindrical fuel tanks, each holding 2 gallons of napalm mixture, were mounted in a backpack frame. A smaller pressurized nitrogen tank provided propellant pressure of 300 to 375 pounds per square inch. The operator controlled everything through a pistol grip attached to the wand, a 4-foot metal tube with a nozzle at the end. Pull the trigger, and high-pressure nitrogen forced the napalm through the wand. At the nozzle, an electrically activated igniter powered by batteries in the pistol grip created a spark that ignited the fuel as it sprayed out. The effective range was 40 to 50 yards, though in practice most operators fired at half that distance to ensure accuracy. A fully loaded M2 weighed 68 pounds, 43 pounds of which was fuel. An experienced operator could fire 7 to 10 1 to 2 second bursts before exhausting the fuel supply. Each burst expelled roughly a half-gallon of burning napalm in a cone-shaped spray that covered an area roughly 10 feet wide at maximum range. The weapon's development paralleled America's learning curve in Pacific combat. At Guadalcanal in 1942, Marines had tried to reduce Japanese bunkers with grenades, satchel charges, and point-blank tank fire. Nothing worked consistently. Defenders would retreat into connecting tunnels when positions were attacked, then re-emerge after the assault passed. A bunker could be neutralized 3 times and still be firing an hour later. At Tarawa in November 1943, the 2nd Marine Division encountered the most sophisticated Japanese defences yet constructed. Over 500 reinforced positions, many made of steel-reinforced concrete, protected by seawalls and interconnected by tunnels. The 3-day battle cost 1,000 Marine lives and 2,000 wounded. After action reports identified the bunker problem as critical, traditional weapons simply couldn't neutralize prepared positions efficiently. This was when the Chemical Warfare Service received urgent requests from Pacific commanders. They needed something that could kill defenders inside fortifications, something that could reach into bunkers and connecting tunnels, something that terrified the enemy enough to make them abandon positions they'd sworn to die in. The M2 Flamethrower was that weapon, but not because of what military planners expected. They had envisioned it as a tool for burning defenders out of fortifications. What they discovered was that fire worked as much through psychological impact as actual destruction. The first large-scale deployment of M2 flamethrowers came during the Marshall Islands campaign in early 1944. The 4th Marine Division assaulted Roy Namur on January 31st with flamethrower teams integrated into assault platoons. Lieutenant Colonel Justice Chambers, commanding the 3rd Battalion, 25th Marines, was skeptical. He'd seen the M1 fail repeatedly and considered the new weapon another Chemical Warfare Service fantasy. His opinion changed on the first day of combat. A Japanese strongpoint had stopped his advance, a reinforced bunker with a 75mm gun that had destroyed 2 Sherman tanks and killed a dozen Marines. The position was invisible until you were within grenade range, at which point interlocking machine gun fire from supporting positions made approach suicidal. Chambers ordered a flamethrower team forward. Private First Class Robert Dunlap and his assistant gunner, carrying extra fuel tanks, crawled through the undergrowth until they were 30 yards from the bunker's firing slit. What happened next was recorded in Chambers' after-action report. Dunlap rose to a kneeling position and fired a 3-second burst directly at the firing port. The stream of fire, described by witnesses as looking like orange water under pressure, shot across the distance and splashed into the opening. The napalm stuck to the concrete edges and burned with white-hot intensity. For perhaps 5 seconds, nothing happened. Then screaming began inside the bunker. Not combat shouts or battle cries, but primal human screaming. 3 Japanese soldiers burst from a concealed rear exit, their uniforms smoking. All 3 were shot within seconds, but their panic was absolute. They weren't retreating tactically, they were fleeing in terror. Chambers watched as Dunlap's second burst entered the firing port, and the screaming inside reached a crescendo before cutting off abruptly. When Marines entered the position 10 minutes later, they found 12 Japanese soldiers, dead inside. Only 2 showed burns, the others had died from smoke inhalation and oxygen deprivation. The napalm had consumed all breathable air in the enclosed space, suffocating the defenders who had survived the initial flames. The effectiveness wasn't just about killing, it was about how killing happened. The psychological impact of flamethrowers proved as important as their tactical utility. Japanese soldiers who would charge machine gun positions without hesitation, who would detonate grenades against their own bodies rather than surrender, fled from flames. Something about fire triggered a response that transcended training and ideology. Marine intelligence officers interviewing rare Japanese prisoners found consistent testimony. They feared flamethrowers more than any other weapon. The thought of burning alive overrode their conditioning. Some prisoners admitted they had abandoned positions not because the flames had reached them, but because they had seen what fire did to nearby positions and couldn't face that death. By March 1944, every Marine division in the Pacific had integrated flamethrower squads into their organization. The standard allocation was 3 flamethrowers per rifle company, operated by 2-man teams. The operator carried and fired the weapon. The assistant carried extra fuel tanks, typically 2 to 4 additional loads, and provided security for the operator who was vulnerable during reload and operation. The doctrine evolved rapidly through combat experience. Early operations had used flamethrowers reactively, bringing them forward when a position couldn't be reduced by other means. Units quickly learned this wasted the weapon's potential. The new doctrine called for flamethrowers to lead assaults on fortified positions. The tactic became standardized. Scouts would identify bunker locations. Infantry would suppress firing ports with rifle and machine gun fire. Under this covering fire, the flamethrower team would advance to within 30 yards. A short burst would mark the target with flames. A longer burst would saturate the position. Infantry would assault immediately after, before defenders could recover or reinforcements could arrive. The Battle of Saipan in June 1944 demonstrated the evolved tactics on a large scale. The 2nd and 4th Marine Divisions, supported by the Army's 27th Infantry Division, assaulted an island defended by 30,000 Japanese troops who had built thousands of fortified positions into the rocky terrain. Captain John Armstrong, commanding a company in the 23rd Marines, kept a detailed diary of the campaign. His entries traced the evolution of flamethrower tactics through 25 days of brutal combat. June 15th, first day. Landed under heavy fire. Advancing 500 yards cost 30 casualties. Bunkers everywhere built into the coral ridges. Tried standard assaults. No effect. Brought up flamethrower team. Private Collins hit a bunker from 25 yards. The defenders, maybe 8 or 10 men, came out with their hands up. First time I've seen Japanese surrender without a fight. The flames didn't even reach inside, but the threat was enough. June 17th. We've refined the technique. Use the flamethrower like a pointer. Mark the position with fire, then assault before they recover. Works every time. The problem is fuel. We're going through 20 to 30 tanks per day. Supply can't keep up. Collins is running back to the beach 3 times a day for refills. June 22nd. Lost Collins today. Sniper got him while he was reloading. The flamethrower operators are priority targets. The Japanese have figured out that killing the flamethrower man stops our advance. We're assigning extra riflemen to protect them. It's worth it. Without the flamethrowers, we'd still be on the beach. June 28th. The whole island stinks of burned fuel and worse. We've learned that you don't actually have to kill everyone in a bunker with flames. Often, one burst into the firing port is enough. The smoke and heat make the position uninhabitable. They either come out or they suffocate. Either way, the position is neutralized. The Japanese called them fire devils in their combat reports. Captured documents from the 43rd Division defending Saipan reveal the psychological impact from the defender's perspective. One report from a company commander, dated June 20th, described the American tactics. The enemy advances behind walls of fire. Our men are brave and will die for the Emperor, but they cannot fight fire. When the flame weapons appear, panic spreads. Men abandon positions they would defend to the death against any other weapon. Officers who try to stop retreating soldiers are ignored. The fire is a terror that overcomes duty. I have ordered machine gunners to target the flame weapon carriers first, but they are well protected by supporting infantry. Even killing the operator does not stop them. Another man takes the weapon and continues. We need countermeasures, but I do not know what countermeasures exist against fire itself. The Japanese did attempt countermeasures. They built bunkers with multiple exits, reasoning that defenders could escape flames through alternate routes. This backfired. Marines learned to position riflemen at alternate exits before employing flamethrowers, turning the multiple exits into kill zones. Japanese engineers tried installing blast doors and baffles in bunker entrances to block flame penetration. The napalm mixture defeated this by sticking to the doors themselves and creating sustained fires that heated the interior to lethal temperatures even without flames entering directly. Some Japanese units attempted to target flamethrower operators with concentrated sniper fire and light artillery. This worked to some extent. Flamethrower operators had the highest casualty rate of any Marine specialty. But American doctrine adapted by providing heavy covering fire and smoke screens during flamethrower advances. The most desperate Japanese countermeasure was suicide charges timed. to hit flamethrower teams before they could fire. This occasionally succeeded but required coordination and visibility that jungle terrain rarely provided. More often, these charges exposed the attackers to American rifle fire before they could close distance. The flamethrowers' effectiveness increased as Marine units developed specialized tactics for different fortification types. For bunkers with narrow firing slits, teams learned to fire bursts at a slightly upward angle, allowing gravity to pull burning napalm down into the opening. For cave positions, common in volcanic islands like Iwo Jima, the technique was different. Caves required sustained fire to fill the interior with flames and smoke. Teams would fire continuous bursts while moving laterally to spray different angles into the cave mouth. The napalm would stick to cave walls and burn for minutes, creating an oven effect that killed defenders deep inside the complex. For spider holes, individual fighting positions dug into the ground and camouflaged, a short burst directly into the hole was sufficient. The burning napalm would sink into the confined space, and the defender had nowhere to go. The Battle of Peleliu in September 1944 presented unique challenges that pushed flamethrower tactics to their limits. The island's coral ridges contained over 500 interconnected caves, many of them large enough to hold 100 or more men. The Japanese had turned the entire ridge system into a fortress with multiple levels, ventilation shafts and stockpiled supplies, allowing defenders to survive extended sieges. The 1st Marine Division brought 21 flamethrower teams to Peleliu. Within 3 days, 15 operators were casualties. The remaining teams were so essential that regimental commanders personally directed their employment. The caves required a new technique. Standard flamethrower bursts couldn't reach deep enough into large cave systems. The solution came from Marine engineers who rigged multiple flamethrowers together into what they called a super burner. By connecting 4 fuel tanks to a single wand and using maximum pressure, they could fire sustained bursts lasting up to 15 seconds that reached 70 yards into cave mouths. Sergeant Andrew Hatch, operating one of these improvised systems, described the effect. "We positioned 3 teams at the mouth of a large cave, maybe 15 feet wide and 30 feet high. Intelligence said there were over 100 Japanese inside. We synchronized our fire and hit the opening together. The flames went deep, much deeper than normal. We maintained fire for 10 to 12 seconds, just pouring it in. The roar was incredible, like standing next to a jet engine. When we stopped, smoke poured out for several minutes. We waited, rifles ready, but nobody came out. When we finally went in with gas masks 2 hours later, we found 87 bodies. Some were burned, but most had suffocated. The smoke and heat had penetrated hundreds of feet into the cave system. The moral implications of flamethrower warfare troubled some Marines. Burning people alive violated something fundamental about humane warfare. Yet the alternatives were equally horrific. Assaulting fortified positions with rifles and grenades produced massive casualties on both sides. Bypassing positions left enemy troops in your rear. Sealing caves with explosives or bulldozers buried defenders alive. Combat was inherently brutal. The flamethrower was simply more viscerally brutal than bullets. Captain Paul Douglas, a Marine officer who would later become a US Senator, wrestled with this in his memoir. "I hated the flamethrowers. They seemed like weapons from hell, literally. But I also knew that they saved lives. American lives certainly, but probably Japanese lives too. A bunker that might cost 20 casualties to take by assault could be neutralized by one flamethrower team with minimal losses. Yes, the deaths by fire were horrible, but were they more horrible than being torn apart by grenades or shot multiple times? War is horror regardless of method. The flamethrower didn't create that horror, it just made it more visible. The weapon's effectiveness created supply challenges. Each flamethrower operation consumed 4 gallons of fuel mixture. Units operating multiple flamethrowers could go through 100 gallons or more per day of intense combat. The napalm mixture required specific ratios of gasoline and thickening agents, and mixing it incorrectly could make the weapon ineffective or dangerous. The Navy developed dedicated supply chains for flamethrower fuel. Tanker ships carried tons of gasoline and thickening agents. Shore parties mixed the napalm on beaches using portable mixing equipment. Fuel tanks were filled and distributed forward by supply parties who often came under fire. Some of the war's unsung heroes were the supply marines who hauled heavy fuel tanks through jungle and coral to keep flamethrower teams operational. By late 1944, flamethrower tactics had become sophisticated enough that the Marine Corps established formal training programs. At Camp Pendleton in California, the Flamethrower School taught Marines not just how to operate the weapon, but how to employ it tactically. Training emphasized several key principles. First, never operate alone. Flamethrower teams required infantry support to suppress enemy fire and protect during vulnerable moments like reloading. Second, know your fuel status. Running empty in the middle of an assault was a death sentence. Operators learned to count bursts and estimate remaining fuel. Third, use terrain. Approach routes that offered cover were essential. The 68-pound weight made flamethrower operators slow and exposed. Fourth, fire short bursts for marking and long bursts for killing. A 1-second burst marked a target and suppressed defenders. A 3-second burst filled a position with killing fire. Fifth, never stop moving after firing. The flash of a flamethrower burst marked your position for every enemy within line of sight. Fire and immediately move laterally or seek cover. The training was realistic to the point of being dangerous. Trainees practiced on mock-up bunkers with live fire. Accidents happened. Several Marines were burned during training, but the instruction prevented many more deaths in actual combat. The Battle of Iwo Jima in February 1945 represented the apex of flamethrower warfare in the Pacific. The 20,000 Japanese defenders had built the most elaborate fortification system of the war. Miles of tunnels connected over 1,500 pillboxes, bunkers and caves. Every position had multiple exits. Artillery and mortars were positioned in reinforced chambers and could be moved through tunnels to alternate firing positions. The volcanic rock was so hard that conventional explosives barely scratched it. The 3 Marine divisions assaulting Iwo Jima brought 243 flamethrower teams, the highest concentration of the weapon in any Pacific battle. The tactics developed over 18 months of island warfare were employed at scale. The fighting for Iwo Jima lasted 36 days and remains the bloodiest battle in Marine Corps history. The flamethrowers were in constant use. Teams would neutralize positions, refill from supply dumps, and immediately move to the next objective. The average flamethrower operator on Iwo Jima fired his weapon 40 to 50 times during the campaign. The Japanese at Iwo Jima had developed specific anti-flamethrower tactics. Snipers targeted operators specifically. Light machine guns positioned in concealment were ordered to open fire the moment flamethrower teams appeared. Defenders in bunkers were instructed to hold fire until flamethrower teams were within 20 yards, then open up with everything. These tactics worked to an extent. Flamethrower casualties on Iwo Jima exceeded 40%, the highest of any battle. But the weapon remained effective because Marine doctrine had evolved to protect operators through overwhelming supporting fire. Before a flamethrower team advanced, artillery would pound the area, mortars would lay smoke, machine guns would suppress known positions, riflemen would saturate suspected sniper locations. The flamethrower attack came at the end of this preparation, when enemy fire was suppressed and visibility was limited by smoke. Lieutenant Leonard Isaacs, commanding a platoon in the 28th Marines during the fight for Mount Suribachi, described the coordinated tactics. We identified a bunker complex halfway up the mountain. Intelligence said it connected to at least 6 other positions. Standard approach would take days and cost dozens of casualties. Instead, we set up a support base with machine guns and bar teams. Artillery fired white phosphorus to screen our advance. The flamethrower team, led by Corporal Harrell, moved up the left flank while we poured rifle fire into every suspected position. Harrell got to within 20 yards and hit the main bunker with 3 long bursts. The flames went in and we could hear screaming. Then, he shifted and hit 2 adjacent positions. The whole complex was connected underground, and the smoke from one position filled all of them. Defenders started coming out of exits 50 yards away from the flames. We were positioned to cover those exits. We killed 23 Japanese in about 3 minutes, and the whole complex was neutralized. Total American casualties, 1 rifleman with a minor shrapnel wound. Without the flamethrower, that position would have cost us a platoon. The weapon's psychological impact reached its peak at Iwo Jima. Japanese soldiers who had held positions against every other weapon would abandon them when flamethrowers appeared. This wasn't universal, many defenders died at their posts, but the frequency of withdrawals in the face of flames was notable enough that Marine commanders commented on it in their reports. Major General Graves Erskine, commanding the 3rd Marine Division, noted in his after-action report, "The flamethrower has proven invaluable in reducing enemy fortifications. Beyond its tactical utility, the The weapon's psychological effect on enemy morale is significant. Enemy troops who show no fear of rifle fire, artillery, or airstrikes demonstrate clear terror of flame weapons. This suggests that increased flamethrower employment could reduce both assault time and casualties in future operations. The Japanese developed one final countermeasure at Iwo Jima that briefly threatened flamethrower effectiveness. They began constructing bunkers with extremely long, narrow entrance tunnels that turned at right angles. The theory was that flames couldn't turn corners, making positions immune to flamethrower attack. The theory was technically correct, but operationally flawed. Marines would simply position a flamethrower at the tunnel entrance and fire sustained bursts that filled the tunnel with smoke and heat. The smoke would flow around corners and into the bunker. If defenders didn't evacuate, they suffocated. Some positions were so well sealed that defenders could survive even this. For these, Marines developed a new technique using demolitions. Engineers would fire a flamethrower into the entrance to mark it with burning fuel, then immediately throw satchel charges of explosives into the flames. The explosion would propagate into the tunnel system, and the pressure wave would push smoke and heat deep into the complex. Very few positions survived this combination. The adaptation and counter-adaptation between American flamethrower tactics and Japanese defensive construction created a brutal evolution in warfare. Every Japanese innovation in fortification design was met with an American tactical adaptation. Every American tactical success prompted a Japanese defensive adjustment. This cycle drove both sides toward increasingly sophisticated and deadly techniques. In the European theatre, American forces also employed flamethrowers, though less frequently than in the Pacific. The terrain difference mattered enormously. European combat involved more open terrain, urban fighting, and traditional fortifications. The M2 flamethrower saw use against German bunkers in Normandy and pillboxes along the Siegfried Line, but it never achieved the central role it held in Pacific operations. The reason was simple: German defenders would surrender when given the opportunity. Japanese defenders, bound by their military code that considered surrender the ultimate dishonor, would fight until killed. This fundamental difference in military culture made flamethrowers essential in the Pacific but supplementary in Europe. By the time of Okinawa in April 1945, the last major battle of the Pacific War, flamethrower tactics had reached full maturity. The 10th Army, consisting of multiple Marine and Army divisions, brought over 300 flamethrower teams to the island. The Japanese defenders, 100,000 strong, had built their most sophisticated defensive system yet, a series of concentric fortification rings across the southern part of the island. The campaign lasted 82 days and became the bloodiest land battle of the Pacific War. Flamethrowers were employed in every major engagement. The weapon had become so integral to American tactics that operations were planned around their availability. Units would wait for flamethrower teams to arrive rather than assault fortified positions without them. The statistics from Okinawa demonstrate the weapon's effectiveness. American forces neutralized over 3,000 fortified positions using flamethrowers. Estimated Japanese casualties from flame weapons exceeded 8,000. American casualties in assaults where flamethrowers were employed were 60% lower than assaults using conventional weapons alone. The weapon had proven its value through the most basic metric, lives saved. But the human cost extended beyond casualties. Flamethrower operators suffered psychological trauma at rates exceeding other combat specialties. Killing with fire, watching human beings burn, hearing their screams, created mental wounds that many operators carried for life. Post-war studies of Marine flamethrower operators found that over 70% reported recurring nightmares about their experiences. Many struggled with guilt despite understanding the tactical necessity of their actions. The moral complexity of flamethrower warfare prompted debate within the military. Some argued that such weapons were inherently inhumane and should be banned. Others countered that the weapon's effectiveness reduced overall casualties and shortened battles, ultimately saving lives on both sides. The debate was never resolved, and flamethrowers remained in American arsenals through the Korean War and into Vietnam. The Japanese perspective on flamethrower warfare comes from limited sources. Few Japanese soldiers who faced flamethrowers survived, and those who did rarely spoke about their experiences. Some testimony exists from post-war interviews with survivors. Former Lieutenant Tadashi Kato, who fought on Okinawa, provided one of the few detailed Japanese accounts of facing flamethrowers. "The fire weapons were our greatest fear. greater than artillery or bombs. Artillery you could survive in deep shelters. Bombs were terrifying but might miss. The fire weapons did not miss. Once the flames entered a position, there was no survival. The Americans would coordinate their attacks perfectly. First artillery, then mortars, then smoke, then the fire weapons while we were still disoriented. The fire would come from angles we couldn't cover. It would stick to everything and burn with intense heat. The smoke was toxic. One breath could make you unconscious. We lost more men to the smoke than to the flames themselves. Our orders were to defend to the death, and most men followed these orders against every weapon. But against fire, some men broke. I saw soldiers, good soldiers, abandon positions when they saw the flames coming. The shame of this was great, but the terror of fire was greater. We called the operators fire demons, not because they were evil, but because they brought an unstoppable death. You could hide from a rifle bullet, dodge a grenade, survive a shell hit. You could not hide from fire in an enclosed position. It found every space, consumed all air, created heat that killed even without touching you. Some men tried to surrender when fire weapons appeared, but often the Americans could not see white flags through the smoke and flames. Many who tried to surrender were shot as they emerged because the Americans could not know if they were attacking or surrendering. The fire weapons made surrender difficult even for those who wanted to. By August 1945, when the atomic bombs ended the war and prevented the planned invasion of Japan, American forces had stockpiled thousands of flamethrowers for Operation Downfall, the assault on the Japanese home islands. Intelligence estimated that Japan had fortified every beach, city, and mountain with positions similar to those encountered on Okinawa. The planned operation called for flamethrowers in unprecedented numbers, possibly exceeding 1,000 teams in the initial assault waves. The battles that never happened would likely have seen flamethrower warfare on a scale never before imagined. The Japanese government had ordered civilians to fight using improvised weapons, and American planners anticipated house-to-house fighting across entire cities. Flamethrowers would have been employed not just against military fortifications, but potentially against civilian structures converted to defensive positions. The moral complexity of this scenario is staggering to contemplate. The atomic bombs, whatever their moral calculus, eliminated the need for Operation Downfall and prevented a campaign that would have used flamethrowers against a mixture of military and civilian defenders in ways that would have dwarfed all previous employment. The post-war assessment of the M2 flamethrower recognized it as one of the decisive weapons of the Pacific War. The Army Chemical Corps calculated that flamethrowers had been directly responsible for neutralizing over 15,000 Japanese fortified positions across the island campaigns. Estimated Japanese casualties from flame weapons exceeded 30,000, though this number is uncertain due to the nature of the weapon's effects. Many defenders killed by smoke inhalation or oxygen deprivation were not visibly burned, making accurate casualty assessment difficult. The weapon's impact on American casualties was harder to quantify but significant. Comparative studies of battles where flamethrowers were widely employed versus similar battles where they were scarce showed dramatic differences in casualty rates. At Tarawa, where few flamethrowers were available, the Marine casualty rate exceeded 30%. At later battles like Iwo Jima and Okinawa, where flamethrowers were employed extensively, casualty rates in specific assault actions dropped to 10 to 15%. The difference represented thousands of American lives, yet the weapon's effectiveness came with costs beyond the obvious. The production of napalm and flamethrower fuel required petroleum resources that were in high demand for aviation fuel and naval operations. The specialized training of operators required time and facilities. The psychological toll on operators required additional medical support, and in some cases limited their combat effectiveness over time. The M2 flamethrower remained in American service through Korea, where it saw limited use against Chinese and North Korean bunkers in mountainous terrain, and into Vietnam, where it was employed against tunnel systems and fortified villages. Each conflict added to the weapon's reputation and the moral debate surrounding its use. International efforts to ban flamethrowers through the Geneva Conventions gained traction in the 1970s. The weapon was seen as causing unnecessary suffering and having effects that extended beyond military targets. The United States eventually phased out portable flamethrowers, though vehicle-mounted systems remained in limited use. The legacy of the M2 flamethrower in Pacific warfare transcends technical specifications and tactical employment. It represents a moment when technology, tactics, and psychology converged to create a weapon that changed not just how battles were fought, but how combatants thought about battle itself. The Japanese military, which had built its defensive doctrine around fortified positions and fighting to the death, found that doctrine defeated not by overwhelming force, but by a weapon that attacked where they couldn't defend, inside their fortifications, consuming the air they breathed. For American forces, the flamethrower represented a solution to an otherwise insoluble problem. How do you defeat an enemy who has every tactical advantage of prepared positions, who will not surrender, who has studied your methods and built defenses specifically to counter them? The answer was fire, not because fire was more destructive than explosives, but because fire operated on principles that defensive engineering couldn't fully counter. You could build a bunker to withstand artillery. You couldn't build one that didn't require air. The human stories of flamethrower warfare remain difficult to discuss even decades later. Veterans on both sides carried psychological scars from their experiences. American operators struggled with what they had done, even while understanding its necessity. Japanese survivors carried trauma from what they had witnessed and endured. These are not the comfortable narratives of heroic combat, but the messy reality of warfare where survival and horror are inseparable. At the National Museum of the Pacific War in Fredericksburg, Texas, an M2 flamethrower sits in a display case alongside other weapons of the island campaigns. The placard notes its specifications and employment, but the real story is conveyed by a short video interview with a Marine veteran. The recording, made in the 1990s, captures an elderly man speaking carefully about his experiences as a flamethrower operator on Okinawa. "I carried that thing through 37 days of combat. It saved my life and my buddies' lives more times than I can count. But I also know what it did to the men on the other side. I've had 50 years to think about it, and I still don't know if I made peace with it. War doesn't give you good choices, just less bad ones. The flamethrower was the less bad choice for us. For them, it was a nightmare. Both things are true." The M2 flamethrower entered Pacific combat as an experimental solution to a tactical problem. It ended the war as a decisive weapon that had fundamentally altered the nature of jungle and island warfare. In between, tens of thousands of men on both sides experienced what happens when fire becomes a tool of conquest. The jungle warfare of the Pacific became a nightmare for Axis troops, not because of fire's destructive power, but because fire attacked what couldn't be protected, breath itself, in places where defenders thought they were safe. The thunder of artillery announced death from outside. The roar of a flamethrower announced death from within. And in the enclosed spaces of bunkers and caves, there was nowhere left to hide. The technical evolution of the M2 flamethrower during the war years tells a story of continuous refinement driven by combat feedback. The weapon that landed at Bougainville in 1943 was significantly different from the one employed at Okinawa in 1945, though the basic design remained constant. The improvements came from solving problems that only revealed themselves in actual combat. The ignition system was the first major issue. Early M2 models used a simple battery-powered spark igniter, but the humid tropical environment wreaked havoc on electrical connections. Operators reported failure rates exceeding 30% on the first trigger pull. A wet igniter meant the operator had to approach the target carrying live fuel, pull the trigger, watch unignited napalm spray out, then attempt to reignite while standing exposed. Several operators died in exactly this scenario. The Chemical Warfare Service redesigned the ignition system 3 times between 1944 and 1945. The final version used a sealed igniter cartridge with redundant spark plugs and weatherproof connections. The cartridges were replaceable in the field and could withstand immersion in water. Failure rates dropped to below 5%, a critical improvement that operators noticed immediately. Corporal William Kennan, who operated flamethrowers through both Saipan and Iwo Jima, described the difference. At Saipan, I had 2 misfires in one day. You pull the trigger and napalm comes out but doesn't light. You're standing there spraying unignited fuel at a bunker full of angry Japanese. It's pure terror. By Iwo Jima, the new igniters never failed me once. That confidence matters. You approach a position knowing the weapon will fire when you need it. That's the difference between hesitation and decisive action. The fuel mixture itself underwent constant refinement. The napalm formula required precise ratios of gasoline to thickening agents. Too thick, and the fuel wouldn't spray properly, clogging the nozzle or creating short-range globs instead of a coherent stream. Too thin, and it would splash off targets or disperse too quickly, reducing effective range and burning time. The optimal mixture was designated fuel gel napalm type 1. It had the consistency of thick syrup, flowed smoothly through the weapon's plumbing, and atomized at the nozzle into droplets small enough to form a coherent spray, but large enough to carry momentum. When ignited, it burned at 1800 to 200 degrees Fahrenheit for 8 to 12 seconds, depending on how thickly it coated the target. The manufacturing process for this fuel became a significant logistical operation. Mixing stations were established on every island with major American operations. The process required careful measurement, specialized mixing equipment, and quality control to ensure consistency. Poor quality fuel could be worse than no fuel at all. Batches that were too thick could rupture fuel lines under pressure. Batches that were too thin wouldn't ignite reliably. Technical Sergeant Malcolm Price ran a fuel mixing station on Saipan that supplied flamethrower teams for 3 regiments. His operation processed over 5,000 gallons of napalm mixture per week during peak operations. We had detailed mixing charts that specified exact ratios by temperature. The heat in the Pacific affected viscosity, so a mixture that worked perfectly at 70 degrees would be too thin at 95 degrees. We adjusted the formula daily based on ambient temperature. The quartermaster thought we were crazy, obsessing over small percentage differences. But those differences meant life or death for the guys carrying the weapons. A mix that was 2% too thin might not ignite reliably. A mix that was 2% too thick might not spray far enough. We took it seriously. The backpack frame design evolved to address comfort and durability issues. The original frames were adapted from standard infantry backpacks and broke under the stress of combat operations. The weight distribution was poor, causing operators to develop severe back pain after extended use. Straps would fray and break at critical moments. The improved E4 frame, introduced in late 1944, used heavier gauge steel tubing, reinforced stress points, and a completely redesigned harness system that distributed weight across the shoulders and hips rather than just the shoulders. The improvement seems minor, until you consider that operators often carried the weapon for hours before employment, moving through difficult terrain under a load. Private First Class George Hubert, a flamethrower operator with the 1st Marine Division, noted the difference. The old frames would cut into your shoulders after an hour. By the end of a day of movement, you had bruises and raw spots. The new frames were like night and day. You could carry the weapon for hours without the same pain. That matters when you need to be alert and ready to fire at any moment. Exhaustion and pain degrade your effectiveness. The better frame kept us combat ready. The weapons range was a constant source of debate. The official specification listed 40 to 50 yards effective range, but combat experience showed this was optimistic. In practice, most operators fired at 20 to 30 yards to ensure accuracy and effectiveness. Beyond 30 yards, wind could disperse the spray, and the cone of fire became too wide to guarantee saturating the target. This range requirement drove tactics. To get within 30 yards of a fortified position meant crossing what military planners called the kill zone, the area where defenders had clear fields of fire. This required careful coordination with supporting arms. Artillery, mortars, and machine guns had to suppress enemy fire long enough for the flamethrower team to close the distance. The casualty statistics tell the story. Of the 1,473 Marine flamethrower operators who served in the Pacific, 436 were killed in action, a mortality rate of 29.6%. For comparison, the overall Marine infantry mortality rate was approximately 8%. Flamethrower operators were nearly 4 times more likely to be killed than regular infantrymen. The assistant gunners, who carried spare fuel and provided security, had a mortality rate of 22%. These numbers weren't just statistics to the men involved. Units struggled to find volunteers for flamethrower duty. Early in the war, assignment to flamethrower teams was voluntary. By 1945, most operators were assigned rather than volunteering. The job had become too dangerous for units to rely on volunteers alone. Lieutenant Colonel Lewis Puller, one of the most decorated Marines in history, addressed this issue directly in a 1944 speech to his battalion. "I need men for a flamethrower duty. I'm not going to lie to you about what that means. It's the most dangerous job in the infantry. It's also the most important. Every position we take, every objective we secure, depends on those flamethrowers. Without them, we'd still be fighting for the beaches. Men die doing this job, but more men would die if nobody did it. I'm asking for volunteers, but if I don't get them, I'll assign men. Either way, those flamethrowers will be manned because that's how we win battles and go home. The weapons maintenance requirements were extensive and complicated by field conditions. The M2 flamethrower had multiple O-rings, gaskets and seals that could fail if not properly maintained. The pressurized nitrogen tank required careful handling and regular inspection. The electrical ignition system needed dry storage and periodic testing. The fuel tanks had to be cleaned regularly to prevent residue buildup that could clog the system. All of this maintenance had to happen in field conditions, often under fire, always in heat and humidity that degraded materials rapidly. Units developed specialized maintenance protocols. Every evening, flamethrower teams would break down their weapons, clean every component, test the ignition system, check pressure seals, and reassemble everything. This took 30 to 45 minutes of work after a full day of combat operations. The alternative was weapon failure in combat, which was unacceptable. Armourers assigned to flamethrower maintenance became critical specialists. These Marines, often overlooked in combat histories, kept the weapons functional under impossible conditions. They improvised repairs using whatever materials were available, cannibalized damaged weapons for spare parts, and performed maintenance in foxholes by flashlight. Sergeant Thomas McGrath, an armourer with the 5th Marine Division, maintained flamethrowers for his regiment throughout the Iwo Jima campaign. We had a saying, "A clean flamethrower is a working flamethrower." Every night, no matter how exhausted the operators were, we'd break down every weapon. I'd inspect each one personally, find worn O-rings, replace them, find corroded connections, clean them, find damaged fuel lines, repair them. The operators hated me because I was strict about maintenance, but none of my weapons failed in combat. Not one. That's the difference between a dead Marine and a live one. The psychological preparation of flamethrower operators deserves examination. The Marine Corps understood that using fire as a weapon created unique mental challenges. The training program included not just technical instruction, but psychological conditioning to prepare men for what they would experience. Training instructors would show footage of flamethrowers in action, including graphic footage of the weapon's effects on human targets. The goal was to desensitize operators before combat, so they wouldn't hesitate when faced with the reality. The footage included captured Japanese, training films showing their soldiers being hit by flamethrowers, forcing American trainees to confront exactly what they would be doing. This approach was controversial even within the military. Some argued it was necessary pragmatism, preparing men for the psychological reality of their mission. Others felt it was unnecessarily brutal and risked creating psychological problems before men even reached combat. The debate was never resolved, but the training continued throughout the war. Private First Class Anthony Benedetto, later famous as singer Tony Bennett, went through flamethrower training in 1945, though he never served as an operator. The training was intense and disturbing. They showed us what the weapon did to people. It wasn't sanitized or abstract. They wanted us to know exactly what we were signing up for. Some guys couldn't handle it and washed out of the program. I don't blame them. It takes a certain mindset to use fire as a weapon against other human beings. The cultural impact of flamethrowers extended beyond the battlefield into American war propaganda. The weapon appeared frequently in combat footage, newsreels, and magazine articles. The imagery was powerful. Dramatic footage of Marines advancing with flame weapons made for compelling propaganda that demonstrated American technological superiority and combat effectiveness. However, the propaganda use created tension with the weapon's grim reality. Public relations officers wanted dramatic action shots. Combat photographers were instructed to capture flamethrowers in action. This meant photographers often accompanied flamethrower teams on assaults, one of the most dangerous positions on the battlefield. Several combat photographers were killed while filming flamethrower operations. The footage that reached American audiences was heavily edited. The actual effects of flamethrowers on human targets were deemed too graphic for public consumption. What Americans saw were Marines spraying fire at bunkers. What they didn't see were burning Japanese soldiers or the aftermath inside fortifications. The sanitized version created a disconnect between public perception and combat reality. Sergeant Michael O'Brien, a combat cameraman who filmed flamethrower operations on Okinawa, described the editing process. "We shot hundreds of feet of film. Maybe 10% was usable for public release. The rest was too graphic. People back home didn't need to see what fire actually does to a human body. They needed to see that we had weapons that were effective, that their Marines were winning. The propaganda served a purpose, but it didn't tell the whole truth. The Japanese Military Intelligence Service studied captured M2 flamethrowers intensively, attempting to develop countermeasures and similar weapons. Several intact or partially damaged flamethrowers fell into Japanese hands during the island campaigns, usually when operators were killed before they could destroy their equipment. Japanese engineers reverse-engineered the design and attempted to produce their own flamethrowers. The results were largely unsuccessful. Japan lacked the manufacturing capacity and materials to produce the high-pressure tanks, precision ignition systems, and most critically the napalm mixture that made the M2 effective. Japanese attempts at flamethrower development produced weapons that were unreliable, short-ranged, and prone to malfunction. The Japanese did deploy some flamethrowers, primarily Type 93 and Type 100 models, but these saw limited use and were significantly inferior to American weapons. The Type 93 had a range of only 75 to 80 feet, compared to the M2's 120 to 150 feet. The Japanese fuel mixture was thinner and burned for a shorter duration. Reliability was poor, with high failure rates reported by the few units equipped with these weapons. More revealing than Japan's failed attempts to copy the M2 were their internal assessments of why American flamethrowers were so effective. Captured Japanese documents from 1945 include a technical intelligence report that analysed the M2's design and concluded that American industrial capacity was the key factor. The report noted that the weapon required precision manufacturing, high-grade materials, and complex fuel production that Japan simply couldn't match while fighting a losing war. The document stated, "The American fire weapon represents not just technical sophistication, but industrial capacity far exceeding our own. Each weapon requires materials and manufacturing precision that would consume resources needed for rifles or machine guns. America produces these weapons by the thousands while maintaining production of all other weapons. This demonstrates the impossibility of matching American material output. Our defeat is not due to lack of courage or skill, but to facing an enemy with unlimited industrial capacity." This assessment, written by Japanese officers facing defeat, cut to the heart of why the M2 flamethrower was so significant. It wasn't just a weapon, it was a symbol of American industrial dominance. The ability to produce thousands of complex specialized weapons while simultaneously producing millions of rifles, thousands of aircraft, and hundreds of ships demonstrated a level of industrial capacity that Japan couldn't comprehend when they started the war. The training pipeline for flamethrower operators became increasingly sophisticated as the war progressed. Initial training lasted 2 weeks and covered weapon operation, maintenance, and basic tactics. By 1945, the program had expanded to 4 weeks and included advanced subjects like coordinating with infantry and armor, operating in different terrain types, and dealing with various fortification designs. The curriculum included a surprising amount of chemistry. Operators needed to understand how napalm worked, what made it effective, how temperature and humidity affected performance. This wasn't academic knowledge, it was practical, information that could mean the difference between effective employment and weapon failure. Technical Sergeant Raymond Liu, a training instructor at Camp Pendleton, designed much of the advanced curriculum. We taught these guys to think like scientists and killers simultaneously. They needed to understand combustion, fuel chemistry, pressure dynamics, but they also needed to think tactically about angles of approach, supporting fire, enemy response. It was one of the most intellectually demanding training programs in the infantry. The guys who excelled were usually the ones who could combine technical knowledge with tactical intuition. The weapon demanded both. The medical treatment of flamethrower casualties, both American and Japanese, presented unique challenges. Burn injuries from napalm were particularly severe because the fuel stuck to skin and clothing, continuing to burn until smothered or until it consumed all fuel. Traditional burn treatments were often inadequate for napalm injuries. Navy medical corpsmen developed specialized treatment protocols for napalm burns. The first step was immediate smothering of any burning napalm using dirt, sand, or water. Chemical fire extinguishers were issued to units with flamethrower teams specifically for treating fuel burns. Once flames were extinguished, corpsmen would remove any remaining napalm using oil-based solvents, as water alone couldn't remove the sticky residue. The burn injuries themselves were often third degree, destroying all layers of skin and sometimes penetrating to muscle and bone. Treatment required immediate fluid replacement to prevent shock, pain management and prevention of infection. Survival rates for extensive napalm burns were poor given the medical technology of the 1940s. Many casualties died from infection days or weeks after the initial injury. Pharmacist's mate Second Class David Chen, a corpsman with the 3rd Marine Division, treated dozens of napalm burn casualties during the Guam campaign. The burns from napalm were different from other burns we'd see. Deeper, more extensive, harder to treat. The fuel would seep into clothing and keep burning against the skin even after the visible flames were out. We learned to strip casualties immediately and douse them with solvent, then water. The pain was indescribable. We gave morphine, but it often wasn't enough. Many casualties were in shock from the pain alone. The ones who survived the initial injury often died from infection, because we couldn't keep the wounds clean in field conditions. The ethical debates surrounding flamethrower use extended into military legal considerations. The Hague Convention of 1907, which established laws of war that remained relevant in World War II, prohibited weapons that caused unnecessary suffering. Some legal scholars argued that flamethrowers violated this provision because they caused extreme pain and suffering beyond what was necessary to disable an enemy combatant. The American military's position was that flamethrowers were legal because they served a clear military necessity, reducing fortified positions that couldn't be neutralized effectively by other means. The argument emphasized that flamethrowers actually reduce suffering by shortening battles and lowering overall casualties. A position that might take days to reduce with conventional weapons and cost hundreds of casualties could be neutralized in minutes with a flamethrower, theoretically reducing total suffering. This legal and ethical debate continued throughout the war and beyond. It was never definitively resolved, partly because international law was imprecise about what constituted unnecessary suffering, and partly because the military necessity argument was compelling in the context of Pacific Island warfare, where alternatives to flamethrowers were demonstrably more costly in lives. Judge Advocate General Captain William Morrison, assigned to Pacific Theatre Headquarters, reviewed the legal status of flamethrowers in 1944. His memorandum concluded that the weapons were legal under existing international law, but acknowledged the ethical complexity. The flamethrower occupies a grey area in the laws of war. It causes terrible suffering, but so do many legal weapons. High explosive shells, for instance, can cause equally horrific injuries. The question is whether the suffering serves a military purpose or is gratuitous. In the case of flamethrowers employed against fortifications, the military purpose is clear and arguably necessitates the weapon's use. Without flamethrowers, assaulting these positions would require tactics that cause more total casualties and suffering. From a utilitarian perspective, the weapon reduces suffering even as it inflicts it terribly on individual casualties. The integration of flamethrower tanks, specifically the M4 Sherman equipped with the M54 flamethrower system, added another dimension to flame warfare in the Pacific. These tanks replaced the main 75mm gun with a flame projector that could fire napalm up to 120 yards, significantly extending the range beyond what portable flamethrowers could achieve. The flame tanks first saw action during the Marianas Campaign in mid-1944 and proved immediately effective. A single flame tank could neutralize positions that would require multiple infantry flamethrower teams and supporting arms. The armor protection meant the flame tank could approach closer to enemy positions than infantry could, and the vehicle-mounted fuel supply allowed for sustained flame operations. However, flame tanks had limitations that prevented them from replacing portable flamethrowers. The tanks couldn't navigate the rough terrain of many Pacific islands, couldn't enter caves or confined spaces, and were priority targets for Japanese anti-tank weapons. They were most effective in relatively open terrain supporting infantry advances, while portable flamethrowers remained essential for close combat in caves, bunkers, and jungle terrain. Lieutenant James Harding, commanding a platoon of M4 flame tanks during the Philippines campaign, described their tactical employment. We'd support infantry assaults on fortified positions, but we couldn't do it alone. The tanks would suppress positions and hit targets beyond the range of portable flamethrowers, but the infantry team still had to go in and clear the positions thoroughly. Our flame stream was impressive, 120 yards of fire, but it was less precise than what an infantryman could do at 20 yards. The combination worked well. We'd hit a bunker complex from range, suppress and disorient the defenders, then the infantry teams would move in and methodically clear each position. Neither system could fully replace the other. The logistical requirements for sustaining flamethrower operations across the Pacific Theatre were staggering. Each operation required positioning fuel supplies, spare weapons, replacement tanks, and trained operators. The supply chain extended from manufacturing plants in the United States across thousands of miles of ocean to forward supply dumps on combat islands. The 10th Army's operations on Okinawa provide a detailed example. The campaign required 400 flamethrower fuel loads per day during peak operations, equal to 4,800 gallons of napalm mixture daily. This fuel had to be mixed on site to strict specifications, stored safely despite tropical heat, and distributed forward to dozens of units spread across the island. The logistics section assigned 40 men solely to flamethrower supply operations. Supply failures had immediate tactical consequences. When fuel supplies were delayed or inadequate, planned operations had to be postponed or executed, with conventional weapons at much higher cost. The supply officers responsible for flamethrower logistics operated under enormous pressure, knowing that their failures would directly result in Marine casualties. Major Richard Thompson, the 1st Marine Division logistics officer during Okinawa, described the supply challenge. Flamethrower fuel was my nightmare. It required special mixing equipment, careful handling, proper storage. It couldn't be exposed to open flames, obviously. It couldn't get too hot or the properties changed. We had to maintain a 3-day supply forward at all times, which meant constantly moving fuel from the beach dumps to forward supply points. Any interruption in that flow meant operators ran out of fuel, which meant assaults stopped or proceeded without them. I had nightmares about fuel shortages. The weapon was too important to let supply failures compromise operations. The post-war disposition of the massive flamethrower inventory reflected changing military priorities. By September 1945, the United States had accumulated over 14,000 M2 flamethrowers in the Pacific Theatre, with thousands more in depots stateside. The planned invasion of Japan would have required every one of these weapons and more, but Japan's surrender left the military with a massive surplus of specialized equipment. Most flamethrowers were either destroyed, placed in long-term storage, or transferred to training bases. The fuel stocks were more problematic. Tens of thousands of gallons of napalm mixture couldn't be safely stored indefinitely, and was too dangerous to ship home. Much of it was burned in controlled disposals on Pacific Islands, creating massive fires visible for miles. The human disposition was more complex. Flamethrower operators were scattered across Marine divisions and returned home as individuals rather than as units. Unlike infantry platoons that might stay together through demobilization, flamethrower operators had no organizational identity beyond their primary unit. This meant they lacked the support structures that helped other specialists process their combat experiences. Post-war studies of combat trauma found that flamethrower operators had higher rates of what was then called combat fatigue and would later be recognized as post-traumatic stress disorder. The nature of their combat experiences, the intimate violence of using fire as a weapon, the sounds and smells of burning human flesh, created psychological wounds that many operators carried silently for decades. The Veterans Administration eventually recognized flame weapon operators as a special category for psychological counseling, though this recognition came decades after the war. Many operators never received any treatment and struggled with nightmares, guilt, and trauma without understanding that their experiences were shared by hundreds of other men who had done the same terrible but necessary work. Dr. Robert Lifton, a psychiatrist who studied World War II veterans extensively in the 1960s and 70s, identified flame weapon operators as having distinct psychological profiles. The men who operated flamethrowers faced a unique psychological burden. They weren't killing at a distance like artillery crews or bomber pilots. They weren't even killing at rifle range where you might not see your target clearly. They were killing intimately, close enough to see faces, close enough to hear screams, using a weapon that caused visible, prolonged suffering. The psychological impact of this type of killing was profound and lasted long after the war ended. Many of these men carried guilt that they never fully processed or resolved. The technical legacy of the M2 flamethrower extended into the Cold War and beyond. The basic design informed later flame weapons, including the M9 and M2S2 flash systems used in Vietnam. The tactical doctrines developed in the Pacific, particularly the integration of flame weapons with infantry assault tactics, remained relevant in subsequent conflicts involving fortified positions. More significantly, the experience with napalm in flamethrowers led directly to the development of aerial napalm munitions. The same fuel mixture that made the M2 effective could be loaded into bombs and dropped from aircraft, creating area weapons with devastating effects. The aerial napalm used extensively in Korea and Vietnam was a direct descendant of the fuel developed for the M2 flamethrower. This connection between the M2 and later napalm use highlights an uncomfortable continuity in American military technology. The weapon that proved so effective in the morally clear-cut context of fighting Imperial Japan was adapted and employed in more ambiguous conflicts, where the targets weren't always military fortifications but sometimes villages and civilian areas. The technology was morally neutral, but its application raised increasingly difficult ethical questions. The men who operated M2 flamethrowers in the Pacific rarely talked about their experiences publicly. In an era when World War II veterans were celebrated as heroes, flamethrower operators often felt their specific contributions were too disturbing to discuss. Family members might know their fathers or grandfathers had served as Marines in the Pacific, but not know the specific role they'd played. This silence created a historical gap that's only recently being addressed as researchers interview the last surviving veterans. These elderly men, now in their 90s or older, speak with careful consideration about experiences that happened 80 years ago but remain vivid in memory. Their testimony provides irreplaceable insight into the human dimension of flame warfare. Robert Schwartz, a Marine flamethrower operator at Peleliu and Okinawa, finally discussed his experiences publicly in a 2015 oral history interview at age 91. For 70 years, I didn't talk about what I did. When people asked about the war, I'd say I was a Marine in the Pacific and change the subject. My own children didn't know I'd been a flamethrower operator until they were adults. It wasn't something I was proud of, even though I understood it was necessary. I killed a lot of men with fire and I saw what that death looked like. You don't forget that. You don't talk about it at dinner, but before I die, I wanted someone to know the truth. We did terrible things for good reasons. Both parts of that sentence are true and important. The strategic impact of the M2 flamethrower on the Pacific War's outcome is difficult to quantify, but undeniably significant. The weapon didn't single-handedly win the war, but it solved a tactical problem that otherwise might have been unsolvable. Without flamethrowers, the island-hopping campaign would have taken longer, cost more casualties, and possibly failed to maintain momentum. Some military historians argue that flamethrowers were decisive in shortening the Pacific War by making island assaults feasible on acceptable timelines. The alternative to using flamethrowers wasn't fighting without them. It was either bypassing fortified islands and leaving Japanese garrisons intact, or conducting extended sieges that would have prolonged the war significantly. The counterfactual question is impossible to answer definitively, but the evidence suggests that without effective flame weapons, American strategy in the Pacific would have required substantial revision. The cost of the war in both American and Japanese lives would likely have been even higher than the staggering totals actually incurred. Professor Richard Frank, a leading historian of the Pacific War, concluded in his analysis of weapon systems, the M2 flamethrower ranks among the most tactically significant weapons deployed in the Pacific theater. Its contribution to American success was disproportionate to its technical complexity or production numbers. The weapon solved the problem of reducing fortified positions efficiently, enabling the island-hopping strategy that ultimately defeated Japan. Without flamethrowers, or something equivalently effective, American strategy would have required fundamental revision, likely extending the war's duration and increasing casualties substantially. The final accounting of the M2 flamethrowers' role in the Pacific War encompasses multiple dimensions: technical, tactical, psychological, ethical, and human. As a technical system, it represented American industrial capacity and engineering skill. As a tactical tool, it enabled operations that otherwise would have been prohibitively costly. As a psychological weapon, it broke the will of defenders who would die rather than surrender under any other circumstances. As an ethical question, it forced consideration of what methods were acceptable even in pursuit of necessary military objectives. As a human experience, it scarred the men who wielded it and those who faced it in ways that lasted lifetimes. The weapon that turned jungle warfare into a nightmare for Axis troops did so not through any single quality, But through the combination of all these factors, it was effective because it was well designed and reliably produced. It was decisive because it was employed according to evolving tactical doctrine that maximized its strengths. It was feared because it attacked where defenders couldn't protect themselves. It was controversial because it made the horror of combat viscerally visible in ways that bullets and bombs did not. In the end, the M2 Flamethrower stands as a symbol of total war, the application of industrial capacity and scientific knowledge to create weapons of maximum effectiveness, regardless of their disturbing nature. It represents both the best and worst of American military capacity, the ability to identify and solve tactical problems with engineering and mass production, and the willingness to employ terrible means in pursuit of strategic ends. The jungle battlefields, where flamethrowers decided countless small but cumulatively significant engagements, are now silent. The fortifications that seemed impregnable have crumbled or been reclaimed by vegetation. The men who fought there, both those who carried flame weapons and those who faced them, are nearly all gone, but the legacy of those weapons remains in military doctrine, in historical memory, and in the careful ethical considerations that now surround the development and employment of weapons designed to kill through fire. The nightmare of flame warfare in the Pacific was real for all who experienced it. That it was effective doesn't make it less terrible. That it was terrible doesn't make it less necessary given the strategic and tactical realities of the Pacific War. Both truths exist simultaneously, and any honest assessment of the M2 Flamethrower must acknowledge both. The weapon turned jungle warfare into a nightmare, and in doing so helped end a larger nightmare. The men who made that possible, who carried fire into battle, deserve to be remembered not with simple admiration or condemnation, but with the complex understanding that war demands terrible things from ordinary people, and sometimes they rise to those demands at great personal cost.